What did we really find on Mars? Could we find actual fossils there? How was the most detailed 3D map of the universe made? And in Q&A Plus, what's the deal with Iapetus and its huge ridge? All this in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Han Solo, do you think we found marks of past primitive life on Mars? There have been some really interesting discoveries on Mars that have said that maybe one explanation is that this was caused by life, but there are other viable explanations. There are three main discoveries in the last couple of decades that have led people to believe that there may have been life on Mars, or there might still be life on Mars. The first one was the Viking experiment. Viking was a mission sent in the late 1970s to Mars, and it was able to scoop up some regolith and then put water and some nutrients in with the regolith. And then it was detecting if any kind of gas was coming out of the regolith that would be indicative of microbial life living in that regolith. And that it did detect some kind of output of gas, but there have been arguments to this day about what it was that it found. One camp believes that it is evidence of some kind of bacterial life in the regolith on Mars. Another camp believes that this is just some kind of abiotic process, that it's just chemistry, that something reacted. Maybe the perchlorates with the water produced the gases and you got this result. And so right now, if you go and talk to people, some will say that they found life, others will swear that it didn't find life. The other big discovery that happened was that around the Curiosity rover on Mars, they detected an increase of methane in the environment during springtime on Mars. And this led some people to believe that the temperature was warming up and this was causing methanogen bacteria on the surface of Mars to kick into high gear and start to output methane around the environment of Curiosity. But others think, well, maybe it was caused by the rover itself, that maybe it was settling or was rolling over the ground and it was interacting with its environment to release methane into its environment. But other spacecraft have detected what seem to be increases in methane in the area around Curiosity, around Mars. And so one possibility is that there is some kind of bacteria on Mars that has produced this methane into the atmosphere of Mars. But there are other, again, non-biological ways that you could get this, that there could be volcanoes on Mars that are producing methane. And maybe as Curiosity is rolling across the surface of Mars, it is compressing gas in the regolith and is sort of causing it to be expelled around Curiosity. And then the other example, most recent, is a discovery by the Perseverance rover on Mars. And it found this rock that had these stripes in it and these weird little spots in it of iron-bearing compounds. These kinds of rocks are produced by life on Earth. And so this could be an example of some ancient life form on Mars, back when Mars was a lot more habitable early on in its history, that was producing these iron compounds and they were being sort of fossilized into the rock. And Perseverance has taken samples of this rock and now, they need to be brought back to Earth by the Mars Sample Return mission to be able to find out. But the scientists that were involved with this said that they'd essentially exhausted every non-biological source that you could get this kind of formation. And so all that remains, in their opinion, was some kind of biology that was actually creating it. But that doesn't mean for sure that it was life. There could be some non-biological process that they weren't familiar with that could create this. So this is possibly the most important discovery that humanity could make scientifically. Like if we find life on Mars, then that means that life is probably everywhere across the cosmos. And so you got to be sure. And so even if there was a tree on Mars, even if there were aliens waving to us in the cameras on Mars, we would go, I don't know, what are the non-biological ways that you could get this happening on Mars? And people would probably be very, very reticent to fully jump in right away. But if the evidence is overwhelming, eventually we will have a spacecraft go to this location pick up the samples from Perseverance, bring them back home to Earth, and then scientists will be able to study these in the lab to find out whether or not it was truly life. So this is a long, complex detective work to be able to get an answer to this question. Giohondo, is it possible that we may find an actual skeletal fossil on Mars, or would it be all gone by now? If there are skeletal fossils on Mars, and they're not that old, maybe they are hundreds of millions of years old, then theoretically we could find them. It all depends on the preservation, depends on the conditions of Mars. Like, keep in mind that Mars has been incredibly dry, cold, has not had a lot of active erosion on the surface of the planet beyond wind. And on Earth, I mean, we've got water, we've got temperature changes, atmosphere, we've got biological erosion that is going on. There's a lot going on to destroy any archaeological evidence of past life. But on Mars, it is cold and dead. And so but it also doesn't have the same kind of like plate tectonics that can reveal older features. But, here on Earth, they have found examples of bacterial colonies going back to 4 billion years ago. And so theoretically, the same kind of thing could be found on Mars. They're called stromatolites, I think. So they're these bacterial colonies that form these sort of rock formations. And so this is the hope, that we will find these kinds of structures on Mars, and then that would be evidence of some kind of past life form on Mars. But what you're talking about, like, what if there was like a dinosaur fossil, right? Like, that would be very cool. And it would just depend on the conditions of what it was preserved in, and then how much erosion has happened to get to the point where it's at right now. Yeah, it depends on the age. How long ago would there have been animals on Mars? 500 million years ago? So it would be the same thing as Earth. It's time to shout out all the new $5 patrons and above. Bruce Catter, Glenny Pete, Rich in DC, Klaus K, Scott Chelberg, Renee Larique, Joseph Walker, Mikkel Jorgensen, James Carey, and Cyber Benyon. Join the club at patreon.com/universe today. Louis Nelson Smith, can you explain how DESI works, and how is the instrument being used to detect dark energy, and what is dark energy anyway? Yeah, I could try. So DESI is the Dark Energy Spectroscopic Instrument. It is one of the major experiments that are being done to discover or understand the nature of dark energy better. And so the big question, or the effect of dark energy, is that it seems to be accelerating the expansion of the universe. That astronomers went and looked at this very specific kind of supernova, type 1a supernova, that is known to give off a very specific amount of energy when it explodes. You know how much intrinsic brightness is in the supernova. And so when you find one of these objects and you measure its brightness, you know how bright it should be. Therefore, that tells you how far away this thing is. And so when astronomers were measuring all of the type 1a supernova that they were seeing, they found that the ones that were older were farther away than they should be, and what you would expect in the expansion of the universe. And there's this very sort of smooth curve. And it appears that there's this additional expansion that's happening in the universe above and beyond just the regular expansion, thanks to the Big Bang. And so this was coined, this is dark energy. We don't know what it is. We don't know what's causing it. We don't know how it started. It just seems to be that the universe is more than just expanding. The expansion of the universe is accelerating. So once you discover this new thing, once you discover this collection of observations, then you need to make better observations because people have a ton of questions. And so there was a whole bunch of surveys that were developed to be able to help understand this. There is the DES, the Dark Energy Survey, which wrapped up its first, I think, 5 years of its survey, and it was taking images of the sky and then they're using that to kind of measure the galaxy clustering and looking at supernova and things like that. Then there's, of course, Vera Rubin, which has just come online, and it's going to be able to detect tons and tons of supernova, over 1 million of these type 1a supernova. So it will give astronomers much better data on finding these. It's going to find other events related to that. You've got the Euclid mission, which was launched by the European Space Agency, and this is essentially taking infrared images of the sky to determine the composition of galaxies, as well as visible images to see how light is being distorted around galaxies, and that's allows you to kind of measure where the dark matter is. and be able to understand the history of the universe at different time slices. There's the upcoming Nancy Grace Roman telescope, but the one you're talking about is DESI, which is the Dark Energy Spectroscopic Instrument. And this is a ground-based telescope, and it is doing a survey of the night sky. And it just wrapped up. It completed 13,000 degrees of the night sky. The whole sky is about 41,000 degrees. So it's like a little under a third of the entire sky. So what happens is, and this is sort of a technique that's been done for a long time, which is that you want to measure the chemical composition of a galaxy. What they used to do is they would use a plate, like a aluminum plate that they would put in front of the telescope, and it would block all the light from the telescope except for the galaxy. And so they would take the telescope, they'd point it at the region that they were going to look at. They would put this plate in front of the instrument, that the camera that measures it. And then only the light from the individual galaxies would be allowed through these little pinprick holes in the plate. And then they could expand the light from each one of those galaxies to do spectroscopy on that light and determine what that galaxy was made out of. And then you could tell which are the galaxies that are relatively close to us, which are the ones that are very far away, which are the ones that have been heavily redshifted and are seen earlier on into the history of the universe. But it's a laborious process. You can imagine, you can take a new picture, you got to pull out the right plate, put it in front, drill new holes in, right? So with the DESI survey, they have this field of little fiber optic cables that are on these little actuators. And so then they line up, they know all the galaxies they're going to see in the field of view. They line up all the little fiber optic cables to line up perfectly with the positions of the galaxies, and then they take their picture. And so the light from that one galaxy goes down the fiber optics down this one channel, and they're able to separate the light and be able to analyze it separately from all the other stuff that's out there. And that gives you really good, clean data on that. And so what DESI is doing is that they are looking at the history of the universe. They're looking at what was the expansion rate of the universe at different times in its history. And they just wrapped up their 5-year observing campaign. And so are in the process of releasing all the data. And so the scientists are going to be able to use this to calculate. And what you're going to get is just, you'll be able to see, these are the galaxies that we're seeing relatively nearby. These are the galaxies that we're seeing 1 billion light years away. These are the galaxies we're seeing 5 billion, the quasars that we're seeing 5 billion light years away. And then you can measure the expansion rate of the universe at different times in the history of the universe. And that'll allow you to see, is dark energy changing over time? You know, because this is one of the big questions that we have. You know, we know that the expansion of the universe is accelerating, but is it a constant acceleration, or is the actual strength of the dark energy changing? And the initial results from the Dark Energy Survey, the DES, said actually it looks like dark energy is dynamic. It's not this constant, that it appears to be decreasing over time, which is good news, because if it's increasing over time, then that could lead potentially to the big rip, right, where the universe tears itself apart. So it appears that it's the opposite of that, that there is a slight decrease in the amount of dark energy that is entering the universe for every cubic meter of space. But there are 4 different methodologies for measuring dark energy. So you have the Type 1a supernova, you have the galaxy clustering, you have the gravitational lensing, and you have the baryon acoustic oscillations. And the problem is that 2 of the measurements done by the Dark Energy Survey indicate that it is more consistent that the universe is, the amount of dark energy is decreasing. But then 2 of the measurements methods give the opposite. And so that is confusing. That is not what you would expect. And so now we're going to get these additional surveys, the DESI survey, Nancy Grace Roman, Euclid, Vera Rubin, and on and on and on. And so at this time when we have all these questions, where this mystery is unfolding, we also happen to have the perfect tools for the job. That 5 different, brand new, top of the line spacecraft have been launched with the capability to give us an answer on this question. And so we will look back on this time, say 10 years from now, in the way that we look back at pre-Gaia data. Before Gaia, we're like, where are all the stars? Which stars are moving? I don't know. Gaia told us where 1.8 billion stars are, where they're moving, what they're made out of. It's incredible. And that's the same kind of revolution in historical, astronomical, cosmological data that we're about to get, thanks to all of these missions. So DESI is the second one out now. You have the DES, now you have DESI, and we're just going to see more of this information come out over the coming years. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. And this week's bonus question, what's the deal with Iapetus and its huge ridge? I'll put a link in the show notes. All right, those are all the questions that we had this episode. Thank you, everyone who put your questions into the YouTube comments, everybody who joined me for the live show. We do the live show every Monday at 5 p.m. Pacific time right here on this channel. Now, I'm going to answer some questions about the format of the question show. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Barely Roofing, Brian Bodie, Carolyn, Chuck Hawkins, Commander Baylock, Darkfinger, David Gilton, David Matz, Evan Lindstrom, Evan.pro, James Clark, Janice Smith, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Sitz, Michael Purcell, Nordspace, OneStepRanimals.org, follow my nephew at VBrick6994, Ren Kaidu, Richard Williams, Sean Sargent, Stephen Filer Munley, Team 49, Telslips Canada, Vlad Chiplin, Wolfgang Klotz, and Zeldaborg Galactic Defender who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. Luviz says, I missed the longer edited Q&A videos that were like 45 minutes long. They were much more immersive. So up until about 2 years ago, we used to release QAs that were about 45 minutes long. And the QAs came from the live question show that I do every Monday here on the channel. So we would take 2 hours of a live stream and we would edit it down to the best 45 minutes of it. And then we would release that as the question show. And now we release 2 episodes every week that are about 22, 23 minutes long. So if you do the math, we've just turned what was 1 episode into 2 episodes. And the reason we do that is because we got a ton of feedback from people saying 45 minutes is too long. I don't have time for that. I would rather you made your question shows shorter. And so we listened to people's feedback and turned them into 2 episodes. But essentially it's the same thing. It's just split up over 2 episodes. And the feedback was that was good. And the audience retention, as you obey the algorithm, that told us that we were moving in the right direction. This was the right thing to do. I totally get that people want things that are just longer that they can just leave on and just play. And so the decision that we made very recently was that we now make all of the live streams public. So before we were turning them unlisted after the episode wrapped up. And this was to sort of placate the YouTube algorithm so we can get punished for having big, long live streams on our channel, which used to be the case. And now it seems to be fine. So now we have not only made all of the 2-hour live streams public going forward, but we're now going back into our back catalog and cleaning them up and putting the older ones live as well. New thumbnails, sort of trimming them down a bit, but essentially you will have an unlimited number of these longer episodes. And then of course, for the patrons, we do the patrons question show, which is audio only, but it is much longer. So the one that we just released the one this week. It was 3.5 hours long, but they've been upwards of 5 hours long. So if you really want an immersive question show, definitely sign up and become a patron. So I know that we can't win, right? That if we made them longer, then people would say they want them shorter. If we make them shorter, people would say we make them longer. We release them as shorts. People hate shorts. Other people love shorts. We're just gonna keep producing content, and sometimes it won't be perfect for everybody. All right, we'll see you next time.